What's up, guys? Okay, so 52. Basically, just ask about solving this eigenvalue. So this is very easy that we can solve it. So we have two eigenvalue. One is 6, one is 4. So the largest is 6. We choose C. Oh, okay. Okay, 53. And F is a vector. V is a vector space. Polynomial has degree at most 3. So V is a polynomial with degree 3. And that is AI belongs to real coefficient. And the W is a subspace of V with such that 0, 1, and minus 1 is 0. So there's a constant which x minus alpha, x minus 1, x plus 1 is, and alpha is a real number. Okay, so ask about the dimension of V plus W. Basically, dimension of V is equal to 4 because it has 4 real coefficients. And any polynomial in V can be expressed into linear expansion of 1x, x squared, and x cubed. So dimension V is 4, dimension W is 1 because there is a 1 parameter alpha. So dimension V plus dimension W is 5. So the answer is B. The answer is B. Okay, and 54. This is simple that define x to be ax a squared. So if I want it to be homomorphism, I want 5xy equal to 5 of x, 5y. So this is axy a squared equal to ax a squared, ay a squared. So remember that in a group, every element has its own inverse. So I can cancel this a on the left hand side and cancel a squared in the right hand side. So we have xy equals to xa cubed y. And I can cancel x from the left hand side and cancel y from the right hand side. So we have a cube equal to 1. So the equal to e. E means identity. So the answer is E. The answer is E. Okay, 55. Okay, so f is defined to be this. So f of x is this 3x squared plus 3y. F of y is 3y squared plus 3x. And f of x is 6x. And y is 6y. xy and yx is 3. So let me remind you guys that so critical points satisfied f of x equal to f of y equal to 0. And once we find the critical points, we need to calculate the so-called Hessian matrix. So Hessian matrix is fx, x, xy, yx, yy. And there are 3, and plug in the critical points. So there are 3 possibilities. The first one, fx larger than 0 and determine h larger than 0. This means the local minimum. If x is smaller than 0 and determine h is larger than 0, this is the local maximum. if determine h is smaller than 0, this is the saddle point. Okay, so now we have the theorem and we have the function, so we can do the actual computation. Okay, so 3x squared plus 3y equals 0. 3y squared plus 3x equals 0. So x squared is minus y. Y squared is minus x. So we have x squared equals to minus. Okay, so maybe I should do this. I plug this y into y to be minus x squared. So this is x to the fourth plus x equals 0. So we have x squared plus x cubed plus 1 equals 0. So we have x equals 0 or x equals to minus 1. So the critical points have 0, 0, and then minus 1, minus 1. So we have two kind of so one is p, one is q, right? And then you ask you about the property of the p and q. So basically, we just put this data into the Hessian matrix and check whether it's condition 1 or condition 2 or condition 3. Okay, so for 0, 0, oh, by the way, the Hessian matrix is here. 6x, 6y, 3, 3. So for 0, we have 0, 0, 3, 3. And then the determinant is more than 0. So this is a saddle point. And for minus 1, the determinant is minus 6, 3, 3, minus 6. So minus 6 is more than 0, and the determinant is 27, so it's larger than 0, so it's local maximum. Okay, let me shrink. Okay, so this is the whole computational process. So the answer is local maximum and the saddle point. So local maximum P and the saddle point Q. Local maximum P and the saddle point Q. So the answer is C. The answer is C. Okay, so we solved the 52, 53, 54, 55. Be sure to subscribe to my channel if you like me, if you like me, and if you think when I did wrong or I should change my style, then please leave a comment below. I will try my best to make an improvement. Thank you guys.